Hello, hello, hello. Good morning. Good day, everyone. We are going to solve another sample problem. This time, we are going to deal with fluid mechanics. By the way, I am Dr. Ramelo B. Ramirez at your service. So according to our problem, a hose shoots water straight up a distance of 2.5 meters. The end opening on the hose has an area of 0.75 square centimeter. The question is, how much water comes out in minute? So again, we have a hose shoots water straight up a distance of 2.5 meters. The end opening on the hose has an area of 0.75 square centimeter. The question is how much water comes out in minutes. So these are our choices. 13.5 liters A, B 41.5 liters, C 31.5 liters, and D 130.5 liters. So what I am going to show you is a computation for this. So according to our problem, the water shoots straight up at a distance of 2.5 meters. So meaning there is a kinetic and potential energy in the condition. Knowing the kinetic energy is at the bottom of the hose. And it should be equal to the potential energy. So the potential energy is at the top of the hose. So we need to determine, according to the problem, how much water will come out in minutes. So how many liters of water do we have to, we will have at the end of the given period? So for the kinetic energy, it should be equal to the potential energy. And take note that you can have the formula for kinetic energy, which is equals to 1/2 mv squared. And that should be equal to the potential energy, which has a formula of m times g times h. Wherein our value for g is set at a constant of 9.81. And then the value for H, because according to the problem, the water shoots straight up at a certain distance of 2.5 meters, then we will be able to determine the velocity. From the formula of the velocity, we can make use of velocity is equals to square root of 2gh. So the velocity is simply equals to the square root of 2 times 9.81 times you have the height, which is 2.5. So therefore, by calculation, the velocity that we will have is 7.0 and the unit is meter per second. So why do we have to determine the value of this velocity? We can make use of this value of the velocity in determining the volume of water that will come out in a minute. So by simply making use of the formula for discharge Q, which is equals to the product of A times V, wherein A is the area and V is the velocity. So if we are going to make use of the formula Q is equals to A times B, wherein A, according to the problem, the end opening of the hose has an area of 0.75 square centimeter. And then the velocity is in meter per second. So the velocity is equals to 7.0 meter per second. The technique here is that we have to be consistent with the use of the unit. So since the area is in centimeter squared, we might as well express the velocity in terms of centimeter per second. Or you can use meter, so you can convert 0.75 square centimeter into square meter. So what we are going to do is to convert the 7 meter per second into centimeter per second. So that is equivalent to 700 centimeter per second. Now we can use the value of the velocity as well as the area in the determination of the discharge, wherein Q is simply equals to 0.75 square centimeter, multiply it by the velocity, which is 700 centimeter per second. And that we will have Q, which is equals to 525 cubic centimeter per second. And then you convert this to per minute. We have how many seconds? We have 60 seconds for every minute. And since the question is the discharge in minute, so that would mean 1 minute. And that gives us to the value of Q, which is equals to 31,500 cubic centimeter, or that is equivalent to 0.0315 cubic meter. And if you are going to express it in liters, the velocity is equals to 31.5 liters. And that will be our answer. 31.5 liters is our answer to the question, how much water will come out in minutes. So if that would be the case, then our answer will be letter C, 31.5 liters. So again, this is Dr. Ramela B. Ramirez at your service. I shall see you in my next video tutorial. God bless everyone.